Welcome to the second Dynamic Web Client session, where we'll cover many of the updates and improvements that Basis has made to the new client over the past several months. During this session, we'll look at the advancements in several areas, including themes and styling, additional controls, new attributes and directives, a couple of new features, and a few plugins and widgets that are available for use with Basis's latest client, the DWC. Introduction. The previous session introduced the Dynamic Web Client and delved into implementation details to explain how it improves initial load times, styling capabilities, and enables responsive design. This session takes a different approach and focuses on many of the recent developments broken down into a few categories. Styling improvements, covering updates to the DWC's theme engine. New controls, including componentized versions of the BBJ radio button and BBJ navigator, as well as newly implemented controls like the tree and tab controls. New attributes that unlock advanced configuration parameters, such as adding integrated labels to input controls, enabling the tree's built-in search capability, and adding client-side validation to input controls. New directives that give developers greater control over the app's theme and various aspects of the host page's header tags and resources. New features, including embedded DWC, URL routing pattern support, and icon pools. And finally, new plugins and widgets such as the BBj Infinite Scroll and BBj Pull to Refresh plugins. Although these are not technically part of the DWC, they highlight some neat things that are possible in the new client due to its flexible layout options, styling capabilities via CSS variables, and JavaScript integration. Styling improvements. We previously looked at the DWC's light and dark themes, and now there's a new dark pure theme available. Visually, the new theme is very close to the dark theme, as it's basically a desaturated version of the dark theme. That's because it uses pure gray variations instead of tinting the default colors with the primary color. We've updated our UIKit demo to add support for the new theme type, so we can toggle between the two dark themes to see the differences between them. We can also set the app to follow the host operating system setting, and even choose which theme to use for each state. After setting the app to use the new dark pure theme when the system switches to dark mode, we can test the behavior by switching our computer's dark mode on and off. While it's nice to have another theme option, it pales compared to the rest of the theme engine changes. We've added a plethora of new CSS custom properties and even several new groups, such as Overlay, to customize the glass pane or a backdrop behind modal elements like a message box. Shadow, to customize the window and control shadows, such as the drop shadow on a pop-up menu. Cursor, to set the mouse cursor to a standard HTML cursor or a custom image file. Surface, to indicate the elevation of an element. Window, to customize the title bar colors, font weight, etc. During the theme refactor, we made some breaking changes to allow for future growth and to save on space. For example, instead of naming the CSS custom property BBj font size XXXL, the CSS variable is now named BBj font size 3XL. We also shortened some of the property names, so the BBj color primary saturation is now BBj color primary S. One of the more significant changes to the theme system deals with the theme definitions. Instead of defining the light and dark themes independent of one another, the dark theme has been reworked to be a flipped version of the light theme. To get a better idea of what this means, let's look at two of the color variables, BBj color white and BBj color black. In the light themes, the white color is white and the black color is black, as expected. But when we apply one of the dark themes, the colors are swapped. So the BBj color white color is actually black, and the BBj color black is now white. In practice, this means that anyone can define a single theme that works equally well in the light and dark themes. Another aspect of this is that the DWC includes variations of the 7 defined color themes: primary, default, gray, danger, info, success, and warning. Besides the BBjColor primary CSS custom property, the DWC defines primary colors with varying lightness from 5% up to 95% in 5% increments. These colors are flipped when switching from light to dark themes, so if a particular color fits well in one theme, then it's going to fit equally well in the others without having to define two separate themes. Additionally, if the custom theme passes the Web Content Accessibility Guidelines color contrast ratio test for accessibility in the light mode, then it will pass automatically for the dark modes as well. Let's see how using the stepped color variables plays out in real life with a demo. This DWC app includes two sample sections with the same text. The difference between the two sections is that the top section uses discrete colors from the TechCon color palette, and the bottom section uses the DWC's CSS color variables. Even though the colors look pretty similar between the top and the bottom sections, that's only because we're using the light theme. When we change to the dark theme, the top section's colors remain the same, while the DWC flips the colors in the bottom section. Notice that the top section is very difficult to read, but the bottom section remains perfectly legible. To quantify our results, we can turn to the Web Content Accessibility Guidelines and use their contrast ratio definition. That's their way to measure the difference in perceived brightness between the foreground and background colors. And the AA requirement dictates that the text should have a minimum contrast ratio of at least 4.5 to 1. For perspective, their AAA contrast ratio should be at least 7 to 1, so we're looking for higher ratios. We have the WCAG Contrast Checker extension installed, so it's easy for us to determine the exact contrast ratios for the two sections, instead of using vague subjective terms like hard to read. In the light mode, the contrast ratio for the main text is over 11 to 1 for both sections, far exceeding the AA recommended value of 4.5 to 1. Switching back to the dark theme, the top section's contrast ratio is now just 1.5 to 1, whereas the bottom section's is still over 11 to 1. That's a compelling reason to use the DWC's color design tokens, instead of choosing random colors. And remember that we can change the hue and saturation for any of the DWC's 7 defined color themes. So if we want to change the info theme to be teal instead of purple, we can do that in one line of code and all the color variations are updated instantly. But the styling improvements don't stop there. Shadows now use multiple layers to appear more natural, and we've tinted them with the primary color. There's even a new CSS-based ripple effect that provides the user with visual feedback when clicking on controls. And the DWC disables that effect automatically when the user has configured their system to reduce motion. Despite the new custom properties and improvements to the theme engine, the optimizations reduce the size of the themes and improve load performance. New controls. The previous session showed most of the DWC's controls in their finished state, meaning that Basis implemented them as web components. However, the two exceptions were the radio button and navigator controls. Even though they were completely functional at the time, they didn't look like the other controls or use the DWC's CSS custom properties. Going back to the UIKit demo, we can compare the radio buttons in their previous state versus what they look like today. Although the differences may appear subtle, the colors now match, and the new versions animate their state change. The navigator's appearance has changed even more dramatically. The older versions sported buttons that were reminiscent of Windows 95, while the new version's buttons look far more contemporary. We have a demo program for the new navigator, and launching it gives us a chance to test its ability to navigate through a bound record set object. It's also easy to customize, and we can change its foreground and background colors, as well as replace the button text with our own custom text, icons, or both. The icons that I chose are special, as they're part of the Tabular Scalable Vector Graphics icon set. We'll cover icons a little more later on in the session, but the interesting part is that they're included in one of the DWC's icon pools. That means that I don't need to use any image files, the icons are always available, and since they're in SVG format, we can draw them at any size with no reduction in quality. Moving on, Basis has implemented a few more controls since the last session. While the actual number of new controls is small, these controls are far more complex compared to simple buttons and input controls. First up is the BBjTabCtrl. The tab control, like our navigator demo, works great with the DWC's icon pools. Developers can continue to use regular images on the tabs, of course, but now they can choose from literally thousands of icons that are easy to define. And one of the new capabilities is that developers can set the control to be swipeable. This is primarily geared toward running in a touch environment, but it's possible to switch tabs with the mouse by either clicking on the tab or pressing the mouse button down on the body and swiping to change the selected tab. Running the tab demo, we can see that we can change the tab using the mouse on a desktop machine or by swiping on a touch device. It's also possible to move through the tabs using the arrow keys. And since we're now setting focus to an element via the keyboard, the DWC applies a focus ring to the element so that we can tell which part of the app has keyboard focus. The BBjTree is another new control for the DWC, and its killer feature is the optional built-in search capabilities. In one line of code, we can tell the DWC to integrate a fully autonomous search box into the control. That's it. No adding another control, setting icons, adding in a clear button, setting placeholder text, writing callback routines, or dealing with the searching algorithm at all, apart from deciding whether or not it ought to be case-sensitive. Our BBjTree demo illustrates how the search works by providing two tree controls on the window, each with its own built-in search. We can search each tree individually for a particular song, and they remain independent of one another. But there's also a standalone BBjEditBox that we can use to search both trees simultaneously. After setting the standard onEditModify callback, our code only has to set the search term attribute to cause both trees to search for the same text. And since the search works with regular expressions, we can type in a simple example to only display nodes that start with the letter T, or that end with the letter E. Another demo combines the BBjTree's search feature with icon pools. The DWC ships with support for 3 icon pools: Feather, Tabler, and FontAwesome, and we can define our own custom pools with other libraries if desired. The FontAwesome library alone has over 1,000 icons broken down into multiple categories, so we've loaded 2 subsets into a BBjTree for over 1,100 icons. Now we can find icons of interest easily by typing in a search term like arrow or ball. The next new control is the BBjColorChooser, and it has a lot more features than the buoy or GUI versions of the same control. Besides the typical hue, saturation, alpha, and preview capabilities, we can optionally display an eyedropper to select a color anywhere on the screen, and a button to copy the selected color to the clipboard. The editable input field supports multiple color formats, and it will even convert named colors for us. So we can type in a color name such as salmon, and the chooser converts the named color to the appropriate RGB parameters. So if you've ever wanted to know the exact properties that make up the aquamarine color, and who amongst us hasn't, you're now in luck. All the components are optional, including the swatches and the cancel and approve buttons. And I can show or hide the components by checking or unchecking the various checkboxes on the left side of the demo. And speaking of swatches, since they're customizable, we've preloaded swatches for the DWC's colors, material design colors, and even our own TechCon color palette. This makes it easy for us to choose colors from an existing theme or color palette. Whenever we select a color, the cEdit on the bottom left displays all kinds of useful information about the chosen color that we retrieved from the chooser. The code then sets the DWC's primary color hue and saturation CSS custom properties so that we can instantly see how our app looks with the chosen color as its primary color. The color chooser is extremely customizable, and we can modify the appearance of several of its components to affect their size. And we can configure it to display in pop-up mode, meaning that it only shows a small swatch of the current color until we click on it. After doing so, we see the full-blown chooser as a pop-up, so we don't have to dedicate a huge amount of our app's user interface real estate just to include a color chooser. The final few controls are also new to the DWC. The BBJ Draw panel that lets us draw text, lines, shapes, arrows, and more. And the BBJ File Chooser. Basis hasn't quite finished implementing this control yet, but the client and directory versions are functional. Finally, there are two ways for us to debug our programs: using the browser's built-in Developer Tools console and a new version of the mini console. While the mini console is functional, it's still pretty rough around the edges and has a few limitations in its current incarnation. This is an area that we plan to improve upon in the future. New attributes. In addition to the DWC's new controls, Basis has added new functionality to several of the existing controls, such as the BBJ top-level window and BBJ child window. The previous DWC session covered setting a flag on an app's main window to turn on flow layout, and child windows support that same functionality. But now there are two new flags available. The first causes the DWC to create a window as a field set that's similar to a group box. That's especially cool, as developers now have the best of both worlds: a child window that acts as a container for all of the controls within, while looking like a group box with a title section. The last flag causes the DWC to create a simple window without support for a status bar or docked child windows. Those aren't very common for many child windows anyway, and the benefit is that the DWC creates the window in a single div. That's not only more efficient and keeps the DOM size down, but it greatly simplifies setting styles on the window, since there's only one div to manage instead of 3 divs with the traditional child window. Our BBJ child window demo shows all 3 types of child windows: the traditional, the new simple window, and the version that has all the benefits of a window but looks like a group box. Inspecting the page shows the underlying code needed to create all 3 windows, and it's evident that the 2 new window types require much less HTML to build them. Many new control properties and configurations are available as attributes, which may apply to most controls, like the theme and expanse attributes, or may be control-specific. The BBjEditBox demo shows how setting the type attributes on the edit box transforms the edit box into that type of input control. This is similar to TechCon 15's Buoy HTML5 Editions demo, except that it used the BBmig Layout Manager, and this DWC version uses client-side CSS Flexbox to arrange the controls. I set the layout to fill as many columns as possible while keeping the controls a fixed width, so watch how they're arranged as I resize the window. But if I wanted to more closely replicate the columnar nature of the BBmig layout, I can change the flex properties to get a different layout strategy. So now when I resize the window, the controls maintain the number of columns until the window is so narrow that it requires fewer columns. Speaking of attributes, the edit box has a new one called AutoValidate that works with the pattern attribute to allow for optional client-side validation. By setting a couple of attributes on the edit boxes, I can enable basic input validation. This edit box's pattern allows only the upper and lowercase letters A through Z, the comma, single quote, and space characters. As soon as I enter an invalid character, like a number or a question mark, the control and its label turn red to show that the contents are invalid. I also configured the telephone input to auto-validate, so as long as I have a single space, period, or dash separating the number groups, then the contents are valid. That's all the code that's necessary. I don't need to define any callbacks or mess with CSS styles and class names. The validation occurs on the client's browser, so it's quick, and there aren't any round trips to the server. And while we're on the subject of client-side validation, Basis has begun investigating bug 24625, an enhancement request to allow for optional client-side validation functions based on arbitrary developer-defined JavaScript code. The validation that we just saw worked by trying to match the control's text to a supplied pattern. But regular expressions can only go so far when it comes to validations. For more complicated validation routines, we're experimenting with letting developers write a JavaScript function that takes the control's text, runs it through an algorithm to see if it's valid, and ultimately returns true or false to indicate whether the contents are valid. The DWC can then prevent the input from passing form validation until all controls pass their client-side validation routines, and it can then place focus on the first input control that failed its validation check. Many input controls also have a label attribute that creates and places a label next to the control automatically. The obvious benefit is that these labels reduce the developer's load, as they no longer have to create, size, and place a separate text control to act as an input's label. And when we combine these labels with the new succinct API, our code is easier to write, read, and maintain. For years, the BBj window methods that add controls have had signatures that take multiple arguments, including the control's unique ID, X, Y, width and height, title, flags, etc. But because the DWC can now support flow layouts, suddenly many of these parameters have become superfluous. Since we can now control the size and position of the controls via CSS on their containing window, it's not technically necessary to provide the X, Y, width, and height parameters, as they're ignored in that scenario. Besides, the language already supports sizing and positioning controls via the setSize and setLocation methods. So simplified creation methods apply to all clients and follow the pattern that other languages like Java employ. Using the BBj button as an example, the BDT displays these 6 code completion options when we add a button to the window, triple the previous 2 methods. So if we're using flow layout in the DWC, using the BBmig layout manager, or simply employing our own sizing and positioning routine, we can dramatically simplify our code. Continuing with our previous example, we can add a button by conveniently providing just the button's title. Under the covers, BBj is providing the next available control ID on the window automatically. So these 2 statements result in exactly the same button. But there are even more benefits to these type of labels, since they're actually tied to the input control. Our previous validation sample showed that when a control's text was invalid, the DWC changed both the control and its label to the color red. The labels also change color from black to blue when their associated control has focus. They also help to improve accessibility, as narrators recognize them as the input control's label. When we test a simple DWC app that uses BBj static text controls for discrete labels, the accessibility score is lower than we'd expect, due to its reported error of, quote, "form elements do not have associated labels," end quote. Sure, we know that the static texts are labels, but that's only because of their proximity to the input controls. When we change the app to use attribute labels, our accessibility score jumps from an orange 80 to a green 90 because Lighthouse recognizes that now all form elements have labels accessible to narrators. Our DWC attributes demo shows a collection of other noteworthy attributes. We can set attributes on the input D control to include a visible calendar icon that displays the calendar when clicked. We can also configure it to show the calendar when we press the Enter key in the control, and even show the week number on the pop-up calendar. We can use an edit box for passwords, and use an attribute to include an icon that displays the typed password in plain text when clicked. Basis found that to be such a useful feature that we added the same capability to the user authentication dialogues for all clients. It's another example of how Basis's work on the DWC has benefited the other clients as well. Attributes can also change the appearance of progress bars and slider tooltips. We can even specify a custom tooltip expression for the slider that's visible only when sliding. In this example, the slider ranges from 0 to 50, but we set a custom tooltip that displays the actual value of the slider as well as the percentage, which is calculated. And the message box supports several new attributes, including one that blurs the background behind the message dialog. And if we want to customize the amount of blurring, that's possible by setting a new value for the associated CSS custom property. So we can make the background slightly blurry, extremely blurry, or anywhere in between. We can also set themes, colors, and custom icons for the message boxes. The first message box displays in the primary theme, and the second one uses the purple info theme. We've configured this one to be dismissible by clicking the OK button, hitting the space or escape keys, or by clicking anywhere outside of the dialog. Other attributes force the dialog to be full screen, or we can even prevent it from being moved on the screen. Besides their attributes, most controls support customization via control-specific CSS custom properties. For example, the BBjEditBox control has a dozen CSS variables that we can set to custom values to affect its appearance. New directives. In the first DWC session, we touched on the DWC's @element, @root, and @global directives. Since then, we've added several more that open new opportunities and address some long-standing difficulties. For starters, there are a couple of directives that facilitate working with themes: @appTheme and @appThemeSwitcher. The DWC has 3 built-in themes, and it's possible to use the @appTheme directive to allow multiple custom themes to coexist with the DWC's dark and light themes. For an example showing the directives in action, let's take a look at a demo. Our Themes Directives demo has a list box showing the DWC's 3 built-in default themes, Light, Dark, and the Desaturated Dark Pure theme, as well as a custom purple theme and an option to use the theme switcher. The quote, "My custom purple theme" quote is a special case, as we've defined a new theme by setting values for a few of the DWC's CSS custom properties. Taking a look at the code, we can see that the theme is defined using the HTML data attribute, which is commonly used to store custom data that's private to the page or application. By specifying our theme in this format, our custom purple theme is an alternative to the DWC's themes, meaning that it can be used in place of the dark or light theme. It's also possible to wrap our theme in the :root CSS pseudo-class designation, which means that the CSS customizations can work in conjunction with the DWC's light and dark themes instead of replacing them. Now that we've defined our custom theme in CSS, we have to make it available to the page. That's pretty simple too, thanks to directives. We can inject the CSS at the top or bottom of the page using the new @appStyle directive, along with the CSS to inject that's contained in our CSSBang variable. After that, our purple theme is available, and we can switch to it at any time using the @appTheme directive along with the name of the desired theme. So when we select the My Custom Purple Theme item from the list box, the DWC switches to that theme and modifies the font size, family, primary color hue, etc. Our demo program applies themes using the @appTheme directive, which has been available for quite some time. However, we did something new with that example that wasn't possible previously. We used directives to inject CSS into our app at runtime. Let's take a closer look at that and the other directives that are new to the DWC. The @appAttribute directive sets an attribute on the document's HTML tag, and we can use it to set the app's language, text direction, and custom global data attributes. Looking at some examples, we can use this directive to set the app's language, or to configure the app to use the dark theme. It's worthwhile to note that since we need a BBJ top-level window available to use with the directive, setting the language in this manner may occur later on in the process than desired. If that's the case, we could always switch to using embedded DWC to set the language in the actual HTML wrapper, which we'll see a little bit later in the presentation. The @appMeta directive lets us attach or change an existing meta tag in the page's header. Meta tags aren't typically critical to a page, but we can make use of them to set terms used in search engine optimizations, or to set a theme color that some browsers use to color the space surrounding the page. One important use case is that we can configure the viewport and prevent the user from being able to pinch and zoom in a touch environment. We did this for BBjingo at previous TechCons, but we had to resort to embedded buoy in order to access the page's meta tags. The link directives let us attach or change an external resource link to the top or bottom of the page. We can use this attribute to set the browser's tab icon, or to include a link to access Google Fonts from a CDN. That's very useful, as we can then use the font in our application without needing to host it or install it on the client's machine. Choosing whether to inject the resource at the top or the bottom of the page gives us the most flexibility, as there are use cases for both. A resource that is injected at the top of the page is available much earlier on in the timeline, usually before we've added the rest of the controls to the page. In contrast, a resource that we injected at the bottom of the page is handled by the browser at the end of the timeline, after we've already added the controls to the page. The script directives are like the link directives, but these apply to scripts instead of resource links. We can use this directive at the top of the page to load jQuery from a CDN, and then we can execute jQuery scripts later on in our app. There are use cases where we'd want to attach the script to the bottom of the page, such as when we'd want to execute code that affects the controls on the page. In that scenario, we need all of the controls to be loaded before we execute the script, and when we access JavaScript libraries from a CDN like this, we're in control of the version that we want to use, and the CDN ensures that it's loaded quickly from the client's browser and relieves us from having to host the library ourselves. The style directives let us add or change CSS styles, and it's an easy way to set custom styles at runtime, instead of needing to define them in an external file ahead of time and registering the file with the app in Enterprise Manager. We just saw an example of this in the directives demo, where we defined a custom theme and used this directive to inject the CSS into the page. This is a perfect example of how directives can address some long-standing difficulties, as we can make changes to the CSS and see the results without having to re-register the app. This is especially helpful when creating a sample program to give to another developer, as we can keep everything that we need to run our program in a single file. Lastly, the Add App Components directive lets us specify an alternate location for the DWC's component files. That makes it possible to host them on a CDN to ensure that they're delivered to the client quickly, regardless of how close the client is to the BBJ services machine. Now that we have a better feel for the new directives, let's revisit the directives demo and look at how it uses several of those new directives. From the top list, it uses directives to prevent the user from scaling the app on a touch device, to set the browser's tab icon to a Phillips screwhead SVG. That's a link, so clicking on it reveals the scalable vector graphic in all its glory. And here's an example of what it looks like on the Browsers tab. To embed links for the Google fonts used in the app, the main text in this demo is using the Alatzi Google font, and the monospace text is using the ShareTech Mono font. Since we used a directive, our app can use the fonts even if the end user's machine doesn't have them installed. Notice how Google includes instructions on how to use the font on the web on the bottom right. That link is essentially what we're doing when we use the directive in the DWC. To embed the jQuery library, we're using a link to the minified version of the jQuery Slim library, so that we can execute jQuery code later on in the app. To inject CSS that styles the app. In particular, we've styled the middle section of the app where we display the results of querying the app's directives values. And finally, to apply the selected theme when the user chooses one from the list below. The demo program executes the Windows getAttribute method to retrieve the values of the attributes of interest dynamically, and then it places the information in the middle section. That way, we can see how the DWC applied our attributes to the page. For example, the @AppScript top shows our link to the jQuery library on a CDN, and we can ensure that it worked by clicking the button to execute some jQuery code that counts the number of elements on the page and displays the information in an alert. New features. Similar to how we can embed buoy apps in our own HTML page, we can now do the same thing with our DWC apps using embedded DWC. This gives us complete control over the HTML that contains the DWC app, And we can do things like defining a manifest file, setting a theme color, defining home screen icons in various sizes for different devices, and even including pre-connect tags to Google Fonts so that the custom fonts load more quickly. Since we're feeling extra adventurous, we added custom JavaScript to our HTML page to set up a service worker and request desktop notifications. With all of that in place, when we load the page in our browser, Google asks us if we want to translate the page from German into English. That's because we set the page's language to German in the HTML itself. We're also given the chance to opt into the desktop notifications, thanks to Chrome's security policies and our JavaScript code that sets up the notifications. After opting into notifications, we can then use Chrome's developer tools to push a test message to our desktop. This requires a little bit of video magic because macOS temporarily hides all of my notifications while I'm recording my screen in the interest of privacy. But this is the notification that we see after first running the program, saying that we subscribe to the app's notifications, and this is the result of pushing a test notification. All of that was possible because we used embedded DWC and took a deep dive into the world of custom HTML, JavaScript, a manifest file, and a service worker. While many of those capabilities aren't typically needed and can get pretty technical, it's reassuring to know that they're available if needed. Another feature that's new to the DWC is routing pattern support, so we can use URLs to drive the app's user interface. There are several potential use cases for this, and one would be to make a RESTful and user-friendly URL, such as /customers/ and then the customer ID. To access information about a particular customer given their customer number. After implementing routing patterns, Base has also defined a bang cookie path global string. That's because cookies are path-dependent, and apps that use routing patterns may run into a problem where cookies associated with another path are not accessible from the app's current path. To solve this problem, developers can set the STBL string to a global app path to be used for all the cookies. That way, the app can access its cookies regardless of the current URL. Our routing pattern demo sets the app's primary color based on the theme color specified in the URL. When we run it with no extra information in the URL, the primary color is the DWC's default blue. But if we add the /theme/pink text to the URL, the app responds by setting the primary color to pink. Likewise, we can pass in a hue value, like 265 degrees, to cause the app to set the primary color to purple. And if we pass in a color name, like tomato, the app uses the BBjColorChooser's ability to convert colors to a variety of formats to derive a hue value of 9.13 for the tomato and set the primary color appropriately. It also chooses a random Google font from a list, so each instantiation of the app looks a little bit different. Another practical feature is the DWC's icon pools, which simplifies adding scalable vector graphic icons to any control that accepts HTML content. It supports 3 icon libraries by default: Tabler, Feather, and the free version of the Font Awesome icons. Our previous tree demo let us search through some of the Font Awesome icons, but what if we have our own preferred set of icons that we want to use instead? And what if they're not in SVG format? In that case, we can define our own custom icon pool and configure it to use our image files, regardless of whether they're in SVG, PNG, or JPEG format. When we create our custom pool, we define how the DWC finds the icon files, so we can configure it to load the icons from a CDN or even a local JEDI directory. This code shows how we can define our own icon pool and configure it to load the images from our local JEDI directory. Our custom icon pool takes this concept and runs with it, adding 3 new custom icon pools based on even more free SVG icon library sets. Now we've got access to a few thousand more icons, so we can search for Git, for example, to show several icons relating to the Git process. New plugins and widgets. Now that we've seen all of the new features and capabilities that Basis has added to the DWC, let's look at some of the new plugins and widgets that these features have enabled. While some of them can function in the other clients, the DWC simplifies their creation because it supports responsive layouts. It uses CSS custom properties, so it's easy to style a custom component to look like the DWC's BBjCtrls. And they can use directives to inject scripts and CSS. Also, a plugin is a good way to explore a particular type of control implementation without necessarily committing to add it to the language. First up is BBjToast. A toast, if you're not familiar with the term, is simply a notification. We can use a toast to notify the user that the app has successfully saved their configuration, or finished backing up their data files. The toasts are very customizable, and we can set their screen location, their display duration, whether they close automatically or require the user to dismiss them, and much more. We can even add custom buttons with callbacks to get answers to questions. Our BBjToast demo lets us play with the different toast placements and display a toast with yes/no buttons. If we answer yes to whether this is a good demo, the app responds with a custom message box saying that it agrees with us. We can show a toast that will stay on the screen until we close it, and try out some of the built-in themes. Finally, we can show a custom toast with a gradient background and HTML formatted text. The next widget is the BBj Infinite Scroll widget, which lets us fill a list with data and continue adding data to the list as the user scrolls down toward the bottom of the list. It too is customizable and includes a pagination helper class that provides the starting and ending index and the total number of pages. We can set a callback for its on-scroll event so that we can add more data to the list when the user scrolls to the end. There's also a BBj Pull to Refresh widget, which lets the user pull down on a child window to either refresh the data or to retrieve more data when used together with the Infinite Scroll widget. Several of its UI features are customizable, including the actual text used for pulling, releasing, and refreshing. It exposes an onRefresh event so that we can set a callback to refresh our data after the user pulls on the child window. We can see both widgets in action with our Chili Contacts demo, which displays a list of Chili Company customers along with their location and a button to call them on the telephone. The app starts by adding a page full of contacts to a BBj child window. When we scroll to the bottom of the list, we glimpse a busy icon and the custom text, quote, loading more customers, end quote. This widget makes sense when there's a lot of information available, but we don't want to waste time adding tons of data to the list unless the user indicates that they really want to see it. We can also pull down from the top of the list in order to refresh it by reloading all of the data from the database. And if the customer has a phone number on file, the app enables the Contacts telephone button that we can press to initiate a call to the customer. Another interesting plugin is the BBjThread, which is a custom class that assists the developer in running processes in separate threads. Let's run a modified version of its demo that calculates the next prime number greater than a given seed number. In a nutshell, the plugin kicks off a new BBj session for every thread, and the programs share information using BBj namespaces. When we first launched the demo, it provides an absolutely enormous number to use as a seed. Otherwise, finding the next prime number is such a trivial task for today's computers that they can do it instantaneously. To counter that, we'll start with the default number, because that way we'll be able to get more accurate timing results. We'll initially start a single thread just to get a feel for how it works, and the top right status shows that we have one running thread. After completion, the program logs the seed number, the next prime number that it found, and the time taken to do the math. The demo keeps a sorted list of unique prime numbers in the rightmost cedit so that we can see how the prime numbers progress. Our test shows that it takes around 7 seconds to get the next prime number. Extending that, it should take over a minute to derive 10 prime numbers if the same interpreter session did all of the calculations sequentially. Instead of sequential calculations, we'll kick off 10 simultaneous sessions with help from the plugin. After all sessions have completed, we see that it took slightly longer to run 10 sessions than it did to run just one. The program shows how useful it can be to run longer running tasks in separate BBj sessions. Although, our demo example falls a bit short in this case because we gave multiple threads a close enough seed value that they sometimes ended up with the same prime number. Demo limitations aside, the plugin has tremendous potential, especially if it's used to run multiple queries in the background. If a dashboard application were to take advantage of this, it could delegate the statistic gathering process to background threads and devote the main thread to creating the charts and the rest of the user interface. The final widget is the collapsible section, which is an accordion-like control that the user can expand and contract to show or hide other BBJ controls contained within. This type of control saves space and helps to minimize an app's complexity by only presenting the user with information that's pertinent. There aren't any callbacks to deal with, as the user is in control of the state, but it provides methods to collapse, expand, and toggle the control, and there are plenty of getter methods for access to the underlying controls. The widget began life in the DWC themer to categorize the various CSS custom properties and help simplify the user interface. Our program is pretty simplistic, but we can see how it took advantage of the DWC's CSS custom properties to have its style match all the other BBJ controls. Whenever we toggle a section, the icon rotates to show the current state, and the control expands or contracts using animations. Our demo takes advantage of the DWC's custom icon pools feature to include an icon with each collapsible section title and the control labels contained within a section. The contact info section is pretty straightforward, but the settings section uses our custom icon pool to set a different disclosure icon, and the class takes care of the rest, including its rotational animation. The calendar entries section nests another extra info collapsible section inside of it, and we can click on the button to generate an iCal invite for all of the information contained in the section. Recap. During the presentation, we looked at many of the DWC's new features and abilities, starting with updates to the theme engine. Those include the addition of several more CSS custom properties, and the DWC's new way of making colors work equally well in both the light and the dark themes. We saw some of the new controls in action, like the searchable BBjTree, the swipeable BBjTabCtrl, as well as the very capable and configurable BBjColorChooser. We explored the new types of child windows, adding attribute labels to input controls, and we even got a sneak peek at client-side validation. The demos revealed how we can add and change resource, script, and style tags at runtime via directives, and how they've simplified dynamic CSS injection. Embedded DWC, routing patterns, and icon pools are new features that give us lower-level access to the underlying HTML page and thousands of icons in a variety of styles. We saw demos of several new plugins and widgets that exploit the DWC's new capabilities, as well as classes like BBjThread that work equally well in all clients. At Basis, we're pretty excited about all the new things that the DWC brings to Business Basic, and there's a lot more planned for the future. New concepts, like the Succinct API and updated user authentication forms, affirm that we're open to improving long-standing aspects of the language. We're still balancing the process of backfilling in elements from the other clients while implementing new capabilities that enable us to explore new web concepts and streamline the development process. Our programmers have enjoyed the new freedom and opportunities that the DWC provides, and we hope that it will inject some excitement into your development projects as it did for us. Questions and answers.